All right, welcome back. I just want to remind everybody that it's probably really important to find something that you love doing in life because you're going to spend a lot of time doing that, like in your career or in whatever thing you decide to do to make money. It's probably going to take a lot of time. So find something that you love and enjoy doing, so that you could spend time doing the things that you love and not the things that you have to do that you resent. Speaking of that, we're gonna move away from kinetic and potential energy a little bit and talk about this new concept called work, which we have talked about in a previous lecture, and we have also encountered in the Quizlet live session that you did last time. Um, but we need to define what this is. We say energy is the ability to do work or make heat. So, what is work itself? So, we've talked about how energy is transformed and transferred, but we haven't really talked about what actually takes place when that happens. And what actually takes place is defined as this physical idea, this concept of work. So, take a moment, be writing these things down as I'm talking. So, work is how much energy is transferred through forces. So work is energy. Work is going to be measured in joules or calories, just like kinetic and potential energy and all the other forms of energy. So when energy is transferred through a force, and remember from Quizlet Live, a force is a push or a pull on an object or a substance. When energy is transferred through forces, we say that work is being done on something by something. And we can account for how much energy gets transferred based upon how much force is applied to that object. So, for example, this red person with a blue leg is applying a force to that black box that is moving across the lower part of the screen. That person with the blue leg is doing work on the box and applying that force and transferring some energy into that object. So, how much energy is being transferred? Well, how much work is being done on that object? It is defined as force times distance. So, how much force is applied and then how far that object moves. It is measured in some strange units. The units are not newtons, which is a weird one to begin with, and not meters, but Newton meters. And a Newton times a meter is a joule. What is even going on here? Well, remember that work is energy, and energy is measured in units of calories or joules. And so we better end up with joules as our units here. Let's talk a little bit about newtons. A Newton, right there, write that down, is equivalent to 0.2248 pounds. So if you hold something that weighs like a quarter of a pound, then you have something about a Newton's worth of force in your hand, so quarter pound. What that also means is alternatively, a 1 pound object is 4.45 newtons. So why are we even talking about pounds in the first place? What is a Newton to begin with? Well, you've probably thought of pounds as, up until this point, as like the weight of something, like how many pounds you weigh or how many pounds something is. And that's totally legit. That is how we measure weight. But what is weight? Well, weight is not just how much something there is. Weight is the force of gravity on how much stuff there is. Weight is the force due to gravity. Weight is a force due to gravity. Go to Jupiter, giant planet, lots of strong, like incredibly strong gravity. You're going to weigh a lot more. Go to Mars, smaller planet, weaker gravity. You're going to weigh less. Is why humans are quote weightless in space where there is no gravity. So we can measure weight, which is the force due to gravity, on mass. We can measure that in pounds, or if we got on board with science and the metric system, we would measure weight in newtons. So this is just our conversion between pounds, which is the force due to gravity on mass, and newtons, which is also the force due to gravity on mass. They're both measurements of force due to gravity and what we call weight. So newtons is a measure of weight as well. What the heck is a Newton? You don't need to write this down. You don't need to write this stuff down right here. You just need to write down this part right here. A Newton is an SI unit of force. So just like pounds, just like we have meters and feet, we also have pounds and newtons. So a Newton itself is equal to 1 kilogram meter per second squared. What does that even mean? Let's talk about that a little bit. If you were to have an object that weighs a kilogram, so think of this in your mind. You've got a large paper clip. A large paper clip weighs approximately 1 gram. And so you have one large paper clip. Now multiply that by 1,000. You have a box with 1,000 large paper clips. If you were to take a box of 1,000 large paper clips and you were to accelerate it, which means you were to change its speed, you were to move it 1 meter the first second, 2 meters the second, 3 meters the third second, you accelerate a box of 1,000 paper clips at an acceleration of 1 meter per second squared, you would have to apply a Newton of force to do that. Another way to think about that is a Newton of force, and all these boxes down here are unfortunately blocking it, you're not going to be able to see it, is what you feel in your hand if you hold the average size apple in your hand. So an apple weighs about 100 grams-ish. So if you're holding an apple that you bought at shopping cart, generally that's about a Newton of force, or about a quarter pound of force. And if you move that object that is 1,000 paper clips 1 meter, you've applied a force times a certain distance, and that is energy. So a kilogram times a meter per second squared, that's your acceleration. And you do that for 1 meter, you've applied that energy. That is a kilogram meter squared per second squared. That is a joule of energy that requires a Newton of force to move 1,000 large paper clips at an acceleration of 1 meter per second squared. I don't know how to explain that any more intuitively. That might have made 0 sense, or it might have made 1% sense, which is getting there, or it might have made a lot of sense. I don't know. But that is about as intuitive as I can possibly make it. And we'll talk about it later on if you're still wondering what is up with that. Yeah, we got 3 minutes left on this video. I think we could do this. Here is your work example. How do we calculate the energy that is transferred during contact that applies a force to an object? How do we calculate work? Work has been done on a 20.3 Newton object. So you take an object that weighs about 5 pounds, because what, 4.5 newtons is a pound. You weigh about 5, take a thing that weighs about 5 pounds. Please be writing this down as I'm writing it. And you, again, abbreviate meters. Work has been done on a 20.3 Newton object to lift it to a height of 14 meters. So you take that 5-pound object-ish and you raise it 14 meter sticks in the air. You are applying energy. You are applying a force to that object. You are transferring energy. It now has gravitational potential energy because it is 14 meters in the air. How much work did you do on that object? Always, always, always WTFF. Write the formula first. Write your instruction manual to follow in your calculation. Work is force times distance. The force in this case is the force that was due to gravity, because we're lifting it against that gravitational potential energy. So it's 20.3 newtons. How do you know? Because we just talked about newtons being a measurement of force. We just talked about weight as the force of gravity. So that should be an indication that that is the part that goes into force. If all fails, and you know the formula, you darn well better know that meters is a measure of distance, and therefore the other number in the math problem is probably the other variable in the formula. So distance, 14 meters, force, 20.3 newtons. For those of you who are charging ahead on your calculators, you should end up with something like this, 284.2 Newton meters. But again, based on that super confusing last slide, a Newton meter is a joule. And don't forget to sig fig it at the end. Your mind should be reeling with all of this knowledge right now, all of this knowledge and all these things to keep track of. You got formulas, you have variables, you have units that turn into other units because of things that they mean. You have sig figs, which you have to recognize that trapped zero right there is significant. That trailing zero counts because there's a decimal. 3 sig figs here, 3 sig figs here. This is a multiplication division problem. A multiplication problem means you have to go with the measurement that had the fewest sig figs, in which case that is 3. So you have 284 joules of work applied to the object to lift it to a height of 14 meters. That is how much energy you would have to apply to lift a 5-pound object 14 meters against gravity. We're going to pause the video for now, or stop the video for now, and move on to the next one.